last class we have seen that how to arrive the geometry of molecules and then how to see the hybridization of particular molecules. Just I will remind today. What's your name, ma? Sham. Early and Saturday. Why you didn't turn up here? Saturday. You must. But you are in online. Down. இப்போ லாஸ்ட் வீக் பண்ண வெளியே டவுன்லோட் ஆயிருக்கு. டவுன்லோட் ஆயிடுச்சா? இல்ல கிளாஸ் எடுத்து
இதுல இருந்து எடுத்துக்கலாம். நீங்க எக்கு
வாட்ஸ்அப்
இவ்வளவு ஸ்லோவா இருக்கு. இங்க டிஸ்கஸ் எனக்கு இது வாட்ஸ்அப் என்ன ஃபைல் சொன்னீங்க?
personal okay.
ஆல்ரெடி இதெல்லாம் எடுத்துருக்கீங்க.
கிளாஸ்ல
ஷேர் ஆயிட்டு இருக்கு. ஸ்கிரீன் ஷேர் ஆகுது. ஸ்கிரீன் ஷேர் கன்ஃபார்ம் பண்ணிக்கோங்க. Those who are online, are you able to hear?
Yes, sir.
Okay.
Shape of molecules. Okay, so if you are provided simple molecules, you have to find out what is the shape, what is the angle. Okay, so some of the things, if you have taken the molecule which is having sp3 hybridization, we know that sp3 hybridized molecules are tetrahedral in shape, whereas some of the molecules like water and ammonia, they are sp3 hybridized, but the shape is not as like tetrahedral, but the bond angle also vary. So why certain molecule bond angle will be different, though they are same hybridization, but their bond angle and the shape will be different. So what is the reason? So we discussed the theory, that is valence electron pair repulsion theory, BSc pair theory. It gives an idea about what is the shape of the molecule. Okay, so if you are considering a molecule, you have to identify the first central atom and the peripheral atom. So which is the least number, that is central atom. If you have taken polyatomic molecule, not a linear diatomic molecule, you take a polyatomic molecule. The polyatomic molecule means it combination of 2, 3, 4, whatever it may be. Okay, so it may be more than 3 or 4 atoms. So you have to identify the central atom and what is the attached atom. In that, you have to calculate what type of electron pairs around your central atom. If the electron pairs are only bond pairs, you will get a symmetrical structure. For example, you have the 2 electron pairs around the central atom. So you can consider you have the 2 atoms. You have considered this will be the atom. Okay, one atom will be attached this side, another atom will be attached this side. So when you are considering the molecule, you are calculating the electron pair. So how many electron pairs there? In the 360 degree, it will be oriented as far as possible. Okay, generally you consider a circle. Circle means 360 degree, no? So you can consider like this, or you can consider like this. So we know that when you are taken Earth, you have the axial position and equatorial position. Axial means the vertical one, Horizontal means equatorial. So likewise, you have to consider the center of the molecule. The center of the circle will be the center of the atom. Okay, so the central atom. The remaining will be the peripheral will be in the 360 degree, maybe axial or it may be equilateral. That we have to make. Suppose if you have look this, if you have only 2 electron pairs, look this picture A. In the 360 degree, it is the central one. These two are attached. If you have 3 electron pairs, only electron pairs, we are not saying it will be a lone pair or bond pair. If it is electron pair, the atom in the center and it will be attached to electron pair in the 360 degree. So if you are calculating the angle, it become how much? It become how much? So it become 180 degree, right? Am I right? So this will be the center. So this will be the center atom. So a molecule atom 1, atom 2 attached. So if you are calculating, the bond angle become 180 degree. So that molecule will be stable at 180 degree. If you are considering 3, the bond angle become this will and this will become 120 degree. Correct? So if you have 4 electron pairs, we have 2 possibilities that in the same circle, like this one will be there and another one will be there. Am I right? Just kindly bear with me. So this will be the center of atom and another atom, another atom, another atom, another atom. If you are considering this will become a square planar. So the bond angle, how much it will become? How much it will become? 90 degree. Okay, but if you are considering tetrahedral, this become 109 degree 28 minutes. So you compare these two, which will become more stable. I told you when you have more than one atom, it will become as apart as possible. The repulsion is minimum when the atoms are as apart as possible. Okay, so you consider the 2 bulky persons seated in the same chapter, it's very difficult. But the 2%, either 2 persons are to be seated, one person on that side, another person this side means that is not that much safe. If they are sitting close together, means the steric intensity occur. Same way, the molecules and the atom have their own atomic and ion gradient. Okay, the ions means ionic gradient, atom means atomic gradient. If it is exists more, then the interaction, then the repulsion will become more. So that's why the water wall repulsions happen. So it get detached. Okay, it go as apart as possible. Same way, the any molecule, if you are taken, the attached atom will be as apart as possible. That's why if you are taken these two, okay, that 4 atoms will be in the tetrahedral dynamics to become like this. Why it is tetrahedral? If you are connecting all the coordinates, you will get 4 phases. That's why it is tetrahedral. Suppose if you have only 5 electron pairs, means you have 3 will be in the 120 degree and 2 will be in the 90 degree. So 2 will be in the 90 degree. So you will get 2 different angles, that is 120 and 90. So 3s are in the 120, 2s are in the 90. Here 4s are in the 109 degree 28 minutes. Suppose if it is 6 electron pair, so if you are considering anything, you are considering, if you are considering this one, then square. Otherwise, if you are considering these, that is also square. Or you are considering 1, 2, 3, 4, that is also will give square. 1, 2, 3, 4, anything if you are connected, they will square. So if you are connected, this central atom with all the 6 attached atoms, you will get upper atom, because bottom you will get 4 spaces and up you will get the 4 spaces. Totally you will get 8 spaces. That's why it's a octahedral shape. Is it clear? So this is the basic idea about how you are getting the linear or triangular or tetrahedral or trigonal bipyramidal or octahedral from the circle. Okay, this, suppose if you have lone pair, what will happen? So you consider, so this will be the equatorial plane, then the atom attached in the equatorial plane is called equatorial atom. The atom which is attached in the axial plane is called axial atom. So if you are considering vertical plane, that is axial. If you are considering horizontal plane, that is a equatorial. Horizontal plane means if you have taken this plate, So this plane will be horizontal. Suppose if you are considering the plane between like this means, then it is a axial. Are you able to understand now? So triangular planar, trigonopyramidal, trigonobipyramidal, and then square planar, square pyramidal, octahedral. I told you when you have 4 atom attachments, tetrahedral. But here I mentioned square planar. Actual geometry will be different. So as per VSP calculation, the 2 lone pair will be occupied the other 2 sides of the octahedral. That's why it is square planar. We'll see one by one. So if you are considering the VSP theory, VSP theory is the simplest without any mathematical calculation. You can say that what is the structure of molecule. First, you have to identify central and peripheral atom and what type of electron pairs around the central atom that you have to find out. How to find out the number of electron pairs? So the total number of electron pairs you can calculate. So total number of electron pairs that is equal to electron pairs. No, that's why the whole thing you have to divide it by 2. Okay, valence electron of the central atom. Okay, what is the central atom? You have to identify the valence electron plus the monovalent atom attached minus number of cation plus number of anion. Then it will give the total value. That divided by 2, it gives the total electron pairs. So you have to calculate the lone pairs. So lone pairs equal to total electron pair minus monovalent attached atom. Okay, you take a molecule. You will say any one molecule. ஏதோ ஒரு molecule சொல்லுங்க. H2. You tell me what is the central atom? What is the central atom? Oxygen. What is the valence electron of oxygen? 1s2, 2s2, 2p4. So 2p4, 2s2. So totally 6. So 6 plus how many monovalent? 2 hydrogen atoms are attached. 2. That divided by 2. Because no cation, no anion, charge will be missing in the molecule. So 8 by 2, it gives 4. So 4 electron pair minus how many monovalent are attached? 2 monovalent. So 4 minus 2 gives 2. So 2 bond pairs, 2 lone pairs. Totally it has 4 electron pairs. If it is 4 electron pairs, the shape of molecular geometry become tetrahedral. Am I right? So we'll see one by one. If you have only 2 electron pairs, the green is the central atom, the reds are attached atom. You will get a linear 180 degree. If you have 3 attached atom, I will rush it. You go and see the video. Okay. Firstly, I will tell you, you go and see the video. So if you have taken the 3, the green will be the central atom, the 3 atoms are attached, you will get a 120 degree, it becomes planar triangle. 4 means tetrahedral shape. 5 means trigonobipyramidal shape. 6 means octahedral shape. Okay. So what are the important postulates of valence bond theory? You have to identify central and peripheral atom, and you have to find out the types of electron pair. So 2 types of electron pair. One will be the bond pair, another one will be the lone pair. The bond pair and lone pair only define the structure of your molecule. Okay. So you have to identify the magnitude of your electron pairs. So magnitude means lone pair occupy more space than the bond pair, which in turns more than the bond pair. So the repulsion, how it will come? When the biggest persons are present means he will occupy more space, isn't it? So the lone pairs which will be occupied by the single atom. Whereas the bond pairs, so if you are taken, you take this green and red, this green and red, this green and red. The electron pairs are in between these two. So the bond pair electrons are localized between 2 atoms. If it is lone pair means that will be present on the single atom. So it will occupy more space. Are you able to understand? Is it clear? So the magnitude of repulsion you are seeing, lone pair will be more than the lone pair, which in turn more than the bond pair. So if your molecules having only bond pairs, then it will be a symmetrical structure. So far we have seen no linear, triangular, tetrahedral, trigonobipyramidal, and octahedral. There are these 5 structures only we will get it. So if you are 7 means pentagonal bipyramidal, it will be more. Okay. And then suppose your attached atom will become double bond or triple bond. Then the magnitude of repulsion will become triple bond greater than the double bond, which in turn is greater than the Suppose if you are having lone pair of electron means the bond angle get decreased. Central atom which will contain more number of lone pair means the bond angle get reduced. Why it get reduced? Because lone pair occupy more space than the bond pair. That's why the bond angle will become get decreased. So you see, when you have only 2 electron pairs, then it becomes linear, 0 electron pair. So you cannot consider, suppose among the 2 electron pairs, one will be the bond pair, another one will be the lone pair, means you will get a linear shape. There is no doubt about it. Suppose if you have 3 electron pairs, among the 3 electron pairs, all are bond pairs, means triangular. In case if you have one lone pair, means the yellow color, the green color, I mentioned, no, this one. This lone pair present means leaving the lone pair, if you are seeing the structure become T-shaped or bent or angular. That shape you can say bent, V-shaped or become angular because the one lone pair present. So what will happen in case if you are having bond angle is 120 degree means, so here the bond angle become less than 120 degree. Why? Due to one lone pair present. So that lone pair occupy more space, so that bond angle get decreased. Is it okay? If you are having 4 lone pairs, okay. If you are having 4 electron pairs, all the 4 electron pairs are bond pair. Then symmetrical structure tetrahedron. In case if you are having one lone pair, so immediately the one corner will occupy that lone pair of electron. Lone pair occupy more space than the bond pair. Definitely this bond angle. So if you are having bond angle 109 degree 28 minutes, so this bond angle become 107 degree. Why the bond angle get decreased? Due to presence of lone pair on the atom. So the lone pair will not present between the atom. It will present on the atom. That you should remember. Okay. Suppose if you have 2 means it occupy two corner of your tetrahedron, this one and this one. Okay. So immediately what will happen? The bond angle get decreased. So this bond angle become 104 degree. So tetrahedron become trigonal, pyramidal or trigonal bipyramidal. Okay. Then it become bent shape. Is it clear, pa? So the next one. If you have 5 means trigonal bipyramidal. If you are removing 1, then you will get the seesaw shape. Seesaw shape, you can see in the park, no? 2 will be balancing, another 2 will be dancing. No? That seesaw shape you will see. Why it becomes seesaw shape? So this lone pair can be on this, or otherwise you can have it in the axial. So one chance become axial, another chance become equatorial. If you are considering if your lone pair present on the equatorial position, okay, so you have here is there, no, here is there lone pair, okay, then you have the interaction 190 degree, 290 degree, 120 and another 120. So if it is the equatorial means 290 degree repulsion, lone pair bond pair repulsion, and 120 degree lone pair bond pair repulsion. Am I right? Suppose if the lone pairs are present on the equatorial, now you consider 1, 2, 3, right? 3 90 degree repulsion. So the first case you have only 290 degree repulsion. Then it become to 120 degree. So it is more. So there will not be much repulsion. Here 290 degree, here 390 degree. So which will become more stable? This one or this one? Are you able to understand? No? So the lone pair occupy more space. That's why we are getting seesaw shape. Okay. In case if you are having 2 lone pairs, so you can think of that 2 will be on the equatorial, or 2 will be on the axial, or 1 equatorial, 1 axial. If you are considering, this become more stable because the lone pair 120 degree, the lone pair bond pair 120 degree, the lone pair bond pair become 90, 290 degree. So 190, 290, 390, 490. Suppose if you are changing into equatorial, you will get more more number of 90-degree repulsion. That's why the T shape become more stable. And then if you are looking 3 lone pairs, so all will occupy in the equatorial, you will get the linear shape. Okay, you may ask, sir, if you are having 2 lone pairs, 1 lone pair up and 1 lone pair down means we have only 2 lone pairs are separated 180 degree. Then it become more stable, no? But the bond pair repulsion, you consider 1, 2, 3 bond pairs will be there. So above 90 degree, below 90 degree, above 3, below 3. Totally 690-degree repulsion will be there, lone pair bond pair. So it will cause more repulsion. So stability become less. That's why you are getting T-shaped molecule. Okay. Then 6. First is 6. If you are removing 1, you will get a square pyramidal. If you are removing 2, you will get a square planar. If you are removing 3, T-shape. Now, how to draw a octahedron? Okay. All of you know how to draw the star, no? Just you put star like this. For those who are in the online, could you hear my voice?
Yes, sir.
So first you draw a line like this, then you connect all the lines in this dots. Then identify the central one. Okay, with this central, you connect all those things. 1, 2, 3, 4, 5, 6. This will be the tetrahedral shape. Sorry, octahedral shape. This will be the octahedral shape. Is it clear now? Is it clear now? Now let's see. It's a hypothetical only. That's why we show that red symbol T shape. So you can take a real molecule. If you are saying beryllium dichloride, so molecular geometry become linear. So the light green. So look here. So the bond angle, it become 180 degree now. So you take the other molecule, methane. So look, 4 atom. Huh? So what is the bond angle? 109 degree, 5 minutes. Or otherwise 109 degree, 20 minutes. That is also same only. Then SR6. Let's look here. All are 90 degrees. So when you are connecting these two, so above you are connecting 1 to the above one, this one you are connecting with 1, 2, 3, and 4. We'll get 4 phase, and bottom 4 means we will get 4 phase. So totally 8 phase. That's why it is a octahedron. Same thing only what you think. So you take the water molecules, you have the central atom, red will be the oxygen atom, and 2 white will be the hydrogen atom. 2 lone pairs are present. So if you show the bond angle, it become 104.5. Electron geometry, tetrahedron. If you are considering all those things. So only if you are considering molecule, it become pentashape. Then TLF3. So look this. It's a T shape, no? But if you are considering the molecule will become trigonal bipyramidal. Could you say no? So one corner and the second corner, third corner. 3 atoms. These 3 will be in the triangle shape. Two lone pairs and this green will become the triangle shape. The above and bottom will become the axial portion. So it gives T shape. And then if you take a molecule like ammonia, look this. Okay, one lone pair. So the bond angle is 107 degree. And then BRF5. So why it square pyramidal? Okay. Actually, you will get the octahedral geometry. Then you will get the square pyramidal. Now we'll go how to find out this one only last class we have discussed. No? Now, how to find out the total electron plus without knowing, without doing this and all. Okay. You know the valence electron of all the atom. So first you remember if it is hydrogen, halogen, it gives single bond. Okay. Oxygen, double bond. And nitrogen, triple bond. You keep it in mind. Okay. Same way, you identify the central atom. A simple molecule, I will work it out. You tell me any one molecule. Tell me, Bob. Tell me any molecule. Barium chloride. Barium chloride, beryllium chloride. Okay. So when you have the barium, it becomes S block element, alkali earth metal. So the valence electron is 2. 1, 2. Okay. So the halogen will become single bond and then single bond. So totally you have 2 bond pairs. Okay. This is keep it in mind. Now as per VSEPR, total electron pairs around the central atom. So what is the valence electron of the central atom? 2 plus 2 chlorine atoms are attached. 2 are monovalent. So 2 plus 2 that divided by 2. So 4 by 2 it gives 2, no? 2 means central atom become like this. 2 will be in the 2 corner. Then the bond angle become 180 degree. So it become linear in shape. Is it okay? Is it okay? Now I tell you, if your total electron pairs is 2, then the shape become linear. 3 triangular, 4 tetrahedral, 5 trigonal bipyramidal, 6 octahedral. This is the original geometry. Total electron pairs. So if it is lone pair percent, the shape will different. For example, tetrahedral. If you are having 1 lone pair, then become pyramidal. If you have 2 lone pairs, it become bent. So that you keep in mind. Okay. Then the total number 2 means the hybridization is. So hybridization means intermixing of atomic orbital to give the hybrid orbital. So for the simple example, you take a red ink and then white ink. When you are mixing red ink and white ink, what you will get? Pink color will get. So pink color is neither red nor a white. But you are taken 10 ml of red, 10 ml of white. You are mixing, you will get a 20 ml. But 20 ml of pink color only will get. So that pink color is known as hybrid one. So it's neither a red nor a white. Am I right? So it has a different properties than your red and white. So same way, hybridization, first you know that it is purely there. No experimental proof for it. Okay. for the bulky molecules, polyatomic molecules, you want to know the shape of molecules means that you can determine through hybridization. Simple process. Okay. The hybridization happen only in the atom, not all the atom. So one of the atom will undergo hybridization. When it will undergo, if the atomic orbitals are in the same energy or equal energy or approximately equal energy, then it undergo hybridization. It will redistribute their energy and gives equal energy and equal shape that will be distributed in the space. That orbital is known as hybrid orbital. Simple example, pink color. It's a mixture of red and white. Neither a red nor a white, but they will mix means it will give the pink color. After the pink color, you will not get red color and white color. Same way, if you have s orbital, spherical in shape, p orbital, double in shape. When you are mixing, you will not get S and P. You will get SP. That will be different from S and P. Okay. So S will be spherical, P will be double. When you are mixing, you will get S and P. So the SP shape will become like this. Spherical S orbital and the double P orbital. Same, you will get so one S and one P. Totally, how much it will combine? 2. So you will get 2 SP. One SP will become like this. Another SP become another SP become like this. 2 SP. So when you are combining in the 360 degree, the 2 SP orbitals will become like this. Okay. Okay. So if you have number 2 means definitely it becomes SP. 1S and 2P. 1P. Okay. So the 3 means SP2. 4 means SP3 or DSP2. Okay. Please remember this will occur only in the complex coordination compounds, not in the simple inorganic molecule. It will occur only in the complexes. And then trigonal bipyramidal SP3, 1S, 3P, totally 4. You have one remain, no? After that, P orbital, what orbital you have? D orbital, no? So it becomes SP3D. Okay. Then 6 means SP3D2 or D2SP3. Okay. You tell me for the barium chloride, what is the hybridization? 2 electron pairs. 2 means what is the hybridization? What is the hybridization? SP. That's all. So SP, linear, 180 degree. All those things you will get to know. So we'll take another molecule. You tell me some other molecule. Shall we do for ammonia? Shall we do for the ammonia? I will tell you the hybridization. Okay. Then VACPR theory. Then the simple one. Now you have the ammonia molecule. Nitrogen is the central atom. So nitrogen going to be the hybridized. So nitrogen means atomic number. What is atomic number? Nitrogen, helium, lithium, beryllium, boron, carbon, nitrogen. 7. So the electronic configuration become 1s2, 2s2, 2p3. So when you have 2s2, 2p3, leave that 1s. Okay, so otherwise you have 1s. When the 3 hydrogen approaches means for the nitrogen, you have 3 unpaired electron in the 2p orbital, right? This 1s orbital, 2s orbital, 2p orbital. So 2p orbital double in shape. Okay, when the s orbitals are spherical in shape. So if you are mixing p orbital, so 3p orbital in 3 direction, x, y, z. For the overlapping directions, very much important is direction. So x orbital can overlap with x orbital. Y orbital will overlap with y orbital. Z will overlap with z orbital. Okay. Px cannot overlap with py. Same way, px cannot overlap with pz. So one orbital in the direction means another orbital in this direction. 3 are mutually perpendicular. So the one which cannot overlap with the other one. If they are in the same direction, then it will overlap. But s orbital is spherical in shape, it can overlap with any other orbitals. Px, py, pz, d orbital, s orbital. So s can overlap with any orbitals, but p can overlap with px, px, py, py, pz, pz. If the overlapping taking place in the bond axis, then it's said to be sigma bond. If it is perpendicular to the bond axis, then it's said to be pi bonds. So what is bond axis? What is bond axis? What is internuclear axis? Very good. Between the nucleus of two atoms, you can consider x will be the bond axis, y will be the bond axis, or z will be the bond axis. So you choose one, the remaining two will become perpendicular to them. For example, you have atom number 1 here, atom number 2 here. When these two are going to overlap, so this will be the bond axis. Okay, so if it is perpendicular to this orbital means this is not bond axis. When the overlapping occur perpendicular to this bond axis, then it's said to be a pi bond. So side-wise overlap. Simple example, you can take these two hands. When you are folding like this means it gives sigma 1. It will be more stable. You can stand for a day. This will be the bond axis. If your orbitals are vertical, okay, like this. When you have the like this means how long you can stay? Is it possible? This is the pi bond. So the pi bond stability is very less than the sigma bond. So you can stand like this, but you cannot stand like this. So the pi bond overlap is sidewise, but it's not that much stable as compared to the sigma bond. But pi bond always exists with the sigma bond. Pi bond is always exists with the sigma bond. That sigma bond can exist independently. For example, if you take a methane molecule, 4 sigma bonds are there. But you take ethylene molecule, 5 sigma bond, 1 pi. So bonding, sigma bonding, pi bonding occur like this. So end to overlap, side by side. Okay, is it clear? Now, in the hybridization, many conditions are there. In this, the orbital energy should be nearly same. For example, the orbital is 150 kilojoule per mole means other orbital will be 160 or 170. It is comparable. One in the 100, another one in the 300 means it's not comparable. So the energy should be same in almost same. Then it undergo hybridization. For the hybridization, empty orbital also it can undergo. Half-filled orbital can also undergo, or otherwise it undergo with a completely filled orbital also. Now you have s orbital. No, this s orbital along with the p orbital it undergo hybridization. Okay, so if it is undergoing hybridization means what you will get 1s and 3p. What it will give? 4 sp3. So the 4 sp3s are in the same energy, same shape. So the 4 lobes it will form. That 4 lobes will be oriented in the space, the tetrahedral manner. So the 4 corners of the tetrahedron will occupy the 4 sp3 hybrid orbital. So what you will get? 1, 2, 3, 4. So 1, 2, 3, and 4. So if you have slightly, because S and P mixing, no. So if you are taking sp3 hybridization, the S character will become 1%. P will be 3. So the sp3 hybrid orbital, you have 1 s orbital, 3 p orbital. So if you calculating S character, how much S character it will be there means 1 divided by 4, right? Totally 4, but you have only 1 S orbital. 1 by 4 means 25% S character, remaining 75% P characters. Okay, now you come to that. So totally how many electron is there? 5 electron is there. So you have to accommodate 1, 2, 3, 4. So fifth one. Now the approaching atom. What is the approaching atom? 3 hydrogen. 3 hydrogen, 1s orbital is there. No, it will overlap with this, with this, with this. So what is 1s 1 of hydrogen, 1s 1 of hydrogen, 1s 1 of hydrogen. Please remember, atomic orbital means 1s orbital plus hybrid orbital, it gives sigma bond. It will take place in the bond axis. This will be one axis, 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 this will be all are bond axis. So 4 will give 4 sigma bond. So 1s orbital, 1s orbital, 1s orbital, 1s orbital. So it gives sigma bond 1, 2, 3, 4. Then you have one more. What is that? Yes, I'm extremely sorry. It's not. So 2, 3. Okay. And the fourth one, it completely filled, no? So that 2 electron will be present on the nitrogen. That is known as lone pair. So the remaining 3 will become hydrogen 1, hydrogen 2, hydrogen 3. So 3 sigma bond. So NH3 you have 3 sigma bond. It will undergo sp3 hybridization. Okay. Now you go to that VSEPR theory. So according to VSEPR, total electron pairs equal to. So what is your electron pairs around the central atom? So NH3, nitrogen. Nitrogen means what is the valence electron? 2 plus 3, 5. 5. How many monovalent attached? 3 divided by 2. So 8 by 2, 4. Correct? 4. 4 means what is the shape? Tetrahedral. Now you have to find out the lone pairs. Lone pairs equal to total electron pair minus monovalent atom. So 4 minus 3 gives 1. So 3 bond pair plus 1 lone pair. You know that the VSEPR theory. So look here. In the VSEPR theory, the tetrahedral shape become trigonopyramidal when it's trigonopyramidal. When it trigonopyramidal. When it has one load. Total electron pair 4 means tetrahedral. From that, pyramidal. So what is the shape? It become pyramidal. When the nitrogen atom will be present, hydrogen 1, hydrogen 2, hydrogen 3. When you are measuring the bond angle, it become 107 degree. Why it is 107 degree? Due to the presence of lone pair on the nitrogen atom, it reduced the bond angle from 109 to 107. Though it is a 4 electron pairs, it should be a tetrahedral shape, but due to the presence of lone pair of electron, this bond angle get decreases. Now I will tell you simple way. You take nitrogen atom. Nitrogen is the central atom, no? 5 valence electron. You put 1, 2, 3, 4, 5. Okay. Then how many monovalent attached? 1 nitrogen, second hydrogen, and third hydrogen. Then you pair it. So 3 bond pairs plus 1 lone pair. Then sp3 hybridization. Then shape will be pyramidal. Is it clear? Instead of doing this very short way, you can do like this. Next molecule, you tell me. One person has to come and do that next molecule. Okay. What are you saying? Okay. Clear, no? You try for H2O. Now you have to answer that. What is the hybridization of oxygen? You try for CH4 methane. Not CH4. BF3. Boron. BF3. You try for PCl5. You try for SF6. Then you try for SO2. First, you try with this method. Okay. Those who are in the online, you can also try, ma. You have to say the answer. What is the molecule I have given? H2O. You, ma. What is it? BF3, SF6, PCl5. Yes, good. You try. All of you try. And say the hybridization and then electron transfer. If you have doubt, you can ask. Yeah, I will tell you. All of you work it out. Then what will be the hybridization? After next time, we have one to setting up. Totally. Two over. What is the shape? 4 minutes. Correct. So, take the data. Then you have two loops. And what will you do? It's degree hybridization. No doubt. It should be different. Two government occupied the loop pair. Then what is the shape? Two V's are the time. One V going on. Without one V, another V. Two V on the same thing. Okay. So if you want that. Look the different shape. How to view that. Connect all this. Okay. So this become one B, another one become another B. Okay, these two are the same thing. If you are writing it between the both, this is towards you, this is away from you. Okay, the shapes are written, they will put dotted line for this dash dash dash. Thick line for this. Thick line means towards. So now you have to prepare the molecule. Oxygen will be the center. Okay. One nitrogen will be on the one hand, another nitrogen will be on the other hand. So here one road hand, here one road hand. Then what is the shape? What is the shape? E shape or paint or C shape? Speed rate. And the X is nothing but this X gives the valence electron of the central atom. 1, 2, 3, 4, 5 valence electron from the center. 3 hydrogen attached. Remaining will become lone pair. So simply, so 4 are next. 3, 1, 2, 3. For the phosphorus, we can put 5. 1, 2, 3, 4, 5. 5 chlorinated atoms. Now we see the hybridization fastly. Okay. You can follow, no doubts, no. So now you tell me which molecule we can take. Among this, which molecule? PCl5 shall we take? PCl5. Phosphorus the central atom. So if you are writing the electronic configuration, what is the atomic number? 15. So when you are writing electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p5. Am I right? 70. So this will be the inside. Oh, I'm sorry. 15. No. For chlorine, I have written. Sorry. So 3p3. So totally you have 5. So this will be the inner side. So this is the valence electron. So 3s2 and 3p. 3s and 3p. So 1, 2, 3, 4, 5. Now you have only 3 atoms are attached. So next the empty orbital become d orbital. 1, 2, 3, 4. 3d orbital. So one of this electron get excited to the d orbital. Then what will be the shape of your molecule? 3s, 3p, and then 1, 2, 3, 4. Now you fill it electron 1, 2, 3, 4, 5. So the phosphorus. Now you have, this is in the ground state, this is in the excited state. Now you have 5 singly filled atom. Now the chlorine will approach. It gives 1 electron, 2 electron, 3 electron, 4 electron, 5 electron. So the chlorine will form bond. So the chlorine can overlap with this. So what is the hybridization? What is hybridization? 1 s orbital, 3 p orbital, and 1 d orbital. So it becomes 1, 2, 3. Okay. 3 will be equatorial, 2 will be axial. No, the energy will become vary. Okay. 4 and 5. So 5 it will give sp3d. So the hybridization is sp3d. Then the shape will become correct. The phosphorus will be the center. Chlorine will be the corner. Okay. Is it okay? This is the shape. So this will be 120 degree. This will be 90 degree. Is it clear? Now valence as per VSEP PCl5. Anything you can put total electron pairs equal to 5 plus 5 divided by 2. 10 by 2. 5. 5 electron pairs means what? Trigonal bipyramidal. That's all according to VSEP over. So anything we can do. It's very simple. So all of you try for BF3, H2O, SF6 and SO2. Okay, SO2 is not in the molecule, but the JE, like that they will ask the questions. Okay, any molecule, if you are going for the competitive exam, you follow this method. then easily you can know. What you should know, this one. This 2 means linear, 3 means triangular, 4 means tetrahedral, 5 means trigonal bipyramidal, 6 means octahedral. It's only for the simple inorganic molecule, not for complex or not for any other things. Okay, simple inorganic molecules you can take this. Okay, well, for the covalent molecules, any covalent molecule you can, if you have taken ionic molecule, it become difficult. Okay, for the covalent you can decide by these methods. Is it clear, all of you? Then what is, you should know how the symmetry, when you have 2 linear, 3 triangular, the 3 to 1 bend over. Okay. So if you 3 means triangular, if you have 1 lone pair, the symmetry is reduced, then the shape should be bent. 3 means triangular, huh? Then if you are removing 1, what is the shape? Bent. And then 4 means tetrahedral. You are removing 1, then it become pyramid. You are removing another 1, then it become. So now you see, I will show. So now you have the central atom. Okay. So if you have 1, 2, linear. Am I right? Then 3, it become. What is this? What is the shape of? What is the shape? Triangular. You are removing 1. What is the shape? Linear, or it become bent. Okay. Now 4. So what is the shape? 2V, 2V, 1V in the up and another V in the down. What is the shape? Tetrahedron. Okay. When you are removing 1, so when you have one introducing lone pair, then what is that? Look here, ma. I am removing lone pair, adding 1, it becomes tetrahedron, right? So instead of tetrahedral, you have 1 lone pair. Then what is the shape? What is the shape? You tell me. You just open your mouth and tell me, no, whether you understand or not. How I can understand? Huh? So what is the shape? At the bottom itself, you have the answer. You can see anything. So when you are removing one thing, again you are adding one thing. So what is this? Bent or V shape or angular, anything you can say. So you are removing one thing and then adding one more. Then it's linear because 3 lone pairs we will not consider, no? So remove 1, 2, 3. 1, 2, 3. Okay. 3 means triangular. We are adding 1 and removing 1. It become bent, no? Correct? 3, 4, 5. What is the shape? 5 means. What is the shape? 3 will be the triangular. 2 will be above and below, no? See, some not 4. It should be 4, no? 5. Look here. You can see, no? 1, 2, 3, 4, and 5. Trigonal, bigonal. Okay. So I'm adding 1 lone pair and removing 1. Now, if you're looking, this is the seesaw, right? Correct? Up and down. Seesaw, no? Correct? Seesaw, so up, down. This is why it's seesaw. Could you see, no? Coming. You could see, okay, fine. Then you are adding 1 more lone pair. So now it is T shape. Two lone pairs in the low, you get T shape. And removing one and adding one more thing, then it becomes linear. So when you are introducing group, how the shapes will change. That's all. You are adding 3, 4, 5, 6 bond pair. So now what is the shape? What is the shape? Octahedral. Okay. You are removing, you are adding one, removing one, adding one. So what is the shape? You will get the square. You will get the square. And then if you are connecting, it's square. Okay. And then adding, removing one, adding one thing. So now we will get the square planar. So whatever geometry you are getting square planar, it's sp3 d2 hybridization. It's not sp3 hybridization. sp3 d2. Only complexes have sp3d and dsp2 hybridization. It gives square. 4 makes. Then you are removing one thing and then adding one. Then again it will become T shape. Okay. 3 bond pairs. Suppose if you are removing one thing and adding one more, then it becomes linear shape. These are hypothetical molecules. Very important. You should know how does it get square pyramidal, 6 square pyramidal, square planar, T shape, linear. 5 is trigonal bipyramidal, and then C-sum, trigonal bipyramidal, C-sum, T shape, linear. 4 means tetrahedral, pyramidal, and then bent. 3 is triangular. The clear no hybridization at next class we have only molecular orbital. Tomorrow we will complete this portion. Now we will wind up this class.
Thank you, sir.
Any doubts? So okay.